Hi, everybody. It's Tyler here at the World Championships. Check in, well, with your defending world champion and Israel district champions. Once again, it's 1690 Orbit. What a phenomenal machine they have brought here. Once again, this is an automation powerhouse that they have brought. I mean, from everything in here, fantastic elevator that they have for that. Of course, I think a lot of people pay attention to that suction and vacuum that they're using too. We'll just overall be talking about every step of this process throughout the way. Of course, what they're doing in terms of automation and vision and so much more as well too. I can't wait to jump back into orbit once again in REEFSCAPE, coming up here on Behind the Bumpers.
This video on fun is brought to you by our viewers, supporters, members, and also in partnership with the following. AndyMark provides superior service with the reliability that teams expect. Check out their sport gearbox and ratchet sport options to their tried and true compliant wheels used by teams all over the world. From mechanical and electrical products to tools and hardware, head on over to andymark.com for your one-stop shop of high quality and affordable solutions. Build your alliance with so many other FRC alumni who go to Kettering University. Every student at Kettering experiences their cutting-edge co-op programs that seamlessly blend the professional and academic worlds. Kettering co-ops are a fully immersive working experience at the leading edge of industry. Head on over to kettering.edu/FRC to learn more about their incredible programs and to get more information.
Jonathan, let's break down the design process of this robot a bit more. Talk to me about just kind of how this all came together, and then we'll be going through your intake and following that system through as well too.
Yes. So this year, we decided that we wanted to have the fastest and shorter coil cycles as possible and to be hard to defend without over-compromising on algae scoring. Now, to achieve this goal, we decided to go for an efficient ground intake together with the lightest and fastest arm and elevator possible, and to keep up with the pace. Now, also, like all 1690 robots, it's critical to us to keep our CG to drive base ratio optimal. So this way, we did this by going for a max frame perimeter and distributing weight correctly. So we can basically drive at full speed with our elevator and arm fully extended and not tip even half an inch. As a means of keeping our CG low, we also opted to put all our motors as low as we could possibly place them, which leads to the fact that this motor right here that powers our intake is actually our highest motor at all times, even when the elevator is fully extended. Wow. And it sits at just 10 inches, which is actually 1 inch shorter than our whole robot from last year. A bit about our swerve. This year we kept running our same swerve modules from last year, our custom swerve, but we just changed our gear ratio to prioritize acceleration over top speed because of this year's short cycles. Now let's move on to our intake. So as I mentioned before, we wanted to have a ground intake capable of intaking coils from any orientation on the field, and to be hard to defend. It's made of 1/4 inch polycarb plates with brass bushings to create a 4-bar linkage. Now, this linkage and the geometry allows it to collapse inwards on impact, so just like this. And it makes it very durable. And in addition, it's very durable to side impacts because of the polycarb's flexibility. So we can intake near a wall, the reef, and the defense robot, and it's very durable. Now, when prototyping, we found out that the optimal wheel's position changes drastically according to the coil's position because the coil is a hard game piece. Now, what we did to solve this problem was we integrated a slot mechanism to our top roller. You can see it right over here. And it allows the top roller to slide upwards when intaking a vertical coil. So this way it goes in any orientation straight into the conveyor system. The conveyor system is basically built of 2 sets of wheels in a V shape that center it to the exact center of the robot each time. It's a very simple design. And now we can actually demo an intake for you.
So on your powered conveyor system that you have for this, I mean, I just love how you just grab and quickly orientates anyway. When you were going through the design process for that, I mean, you mentioned it's simple, but it's so effective for that as well. Did you have to go through any kind of major iterations to get to where you are?
Not really. We did prototype it. We had about 2 prototypes going for this thing, and it worked pretty great. Another fact about it is that it's powered by 2 motors, 2 Kraken X44s, because we did want to have the option to power each side separately in case of the coil getting stuck, so this way it never gets stuck. Another cool fact about our conveyor is we actually wanted it to be very modular because we have wiring and the motors underneath it. So what we did is we made it detachable by only unscrewing 4 screws. And this is possible because the motors that power it actually transfer the power through hex shaft and 3D printed couplers made of onyx, just like you can see over here. So it means that the power is transferred through these, and it's very easy to just attach and detach the whole system because they're just placed on one another.
Love it so far. A lot of great more stuff we can keep going on with this robot. Alon, tell me more about the elevator. And I mean, I know this elevator's been so quick for this, but this vacuum system here too, like I have to admit, like we've seen a couple teams do the vacuum, but when you guys came out with that in your reveal video, I was absolutely blown away. I didn't think anybody would be really going that route, and your effectiveness you have with it's been so cool. So let's walk through kind of all this and how it came together.
We wanted all of the systems that go high up in the air to be as lightweight as possible. And the best way to do that is by not having any motors or gearboxes mounted on them at the get-go. So to do this, we implemented 2 unique solutions. The first one is this differential elevator and wrist setup. It is actually inspired by a design by an alumni from Team 100, the Wild Hats. So as you can see here, we got this 9-meter continuous HTD belt. It was actually a 10-meter belt at the beginning, and we cut it to the wanted length and glued it back together with a special epoxy glue. So this belt runs through the entire elevator and through this pulley on the cartridge right here. And when it pulls on both sides of the pulley in the same direction and speed, it will cause it to move either up or down. But when there's a differential, for example, like this, the arm will rotate. This setup lets us keep both the motors for the arm and the elevator down here in these gearboxes. Another cool fact about our elevator is our custom machined bearing hubs. As you can see right here, we machined those to be about half of the weight of standard off-the-shelf ones, and also provide a hub for our elevator pulleys. Now, manipulator-wise, for the same reasons as the arm, we wanted a system that would not require another motor mounted on it, and that is why we opted to use this universal suction cup that works for both coral and algae. We got this suction cup in the middle. It's just an off-the-shelf product. It works with this for corals, and then this outer silicone seal for algae. And it is actually silicone that we molded at our shop with a 3D printed mold, and it takes about 1 day to create one of these, so we could iterate them really quickly. Now, with all of this weight optimization put together, the entire cartridge, arm, and manipulator weigh about 2.5 pounds altogether, which is more than we could have hoped for in terms of weight. Now, as I said before, the system is powered, the vacuum system is powered at the base of the robot. Below this plate, we got these 2 pneumatic pistons. And when they extend, they create a vacuum that we run through this tube and this E-chain all the way to the vacuum pump, to the suction cup. And the way it works is that we got this motor right here that drives the pistons through a mechanism called a Scotch yoke, which converts the motor circular motion to the piston's linear motion. Now, when testing this mechanism, we saw that one piston was not enough to create constant suction because it does much more work when it's in the middle of its segment rather than the ends. So to solve this, we use 2 pistons, which are offset by half a cycle. So when one is at the peak of the cycle, the other is at one of the ends.
So what I want to ask you on this too, I mean, we've seen a lot of robots that are doing suction for algae, or a few at least for that, but like coral-wise, like what made you like say like, hey, this is actually going to work? Like I know you did the custom work for it, but what actually made you think when you were coming up with the design process, like, oh, let's use suction for the coral too? I mean, that just boggles my mind on how you came up with that.
Yeah, so at the beginning of the season, after choosing concepts that we want to test, we ran prototypes, and one of the concepts was suction. Initially, we thought it also more in the context of algae. but then we luckily saw that it also works great for corals, and it took a couple iterations and finding this specific suction cup that worked great for us, and like the motivation behind the choice for vacuum was really keeping the arm and the manipulator as lightweight as possible. Now let's go over to the climber. This year we chose a very simple climber. It is inspired by Crosstown's robot in 3 days. We got these 2 tubes that latch onto the cage with a magnet that pulls it into place, and the centering 3D pins. And the climb is driven by this winch right here with a ratchet to prevent it from unwinding after the match ends. Mid-competition, we saw that the cage tends to slip out of our climb, so we added those wider wedges at the end of the tubes, and it has worked perfectly ever since.
Let's pass over to Ty, talk more about some of the different aspects in regards to the cameras on the robot. I mean, obviously, when I think orbit, I think automation, right? And just all the great processes that you go in for that. But talking about like some of your alignment, how you're coming about all that, and just how it all came together.
Okay, so first, what we saw this year, we noticed that the target is small and there's not a lot of room for error when placing. So we wanted to see the tags until the end of the placing movement. So that's why we have in this side those 2 limelights, 3Gs, for detecting the reef tags. And we wanted to precisely place on the other side of the robot, over the intake. So we also put another limelight 3 over here in order to see the tags and get a precise location as well. We also have another Ardu cam underneath it that is running photon vision on the Orange 5.5, and we run an HSV mask on it to detect the corals and the white corals on the ground, because there's nothing else on the floor this year that is white. So we calculate the position of the corals using high difference and trigonometry, and then we use that coral position in order to assist the driver during teleop and drive to intake it during autonomous. The assist during teleop is perpendicular to the robot's velocity, and it slows the drivers down when it drives towards it in a fast speed. Our differential this year, we're controlling it with dynamic motion magic. We've run it on the carnivore, and we're changing the acceleration and the max velocity of each motor in order to ensure the synchronization of both of the mechanism during the motion. So none of the systems are overshooting during the motion, and we get a smooth motion all the way. Each year, our design process is to make the robot as easy to drive on as possible. So we want to make as many automations as we can. So every major action of the robot this year is assisted or even automated. From intaking the coral to placing, intaking algae from the reef, and putting in the processor the algae and putting in the net the algae. We try to remove from the driver as much as we can in order to let him be more focused on driving and on doing strategic choices during the match.
So at what point, like when you're going to score and that sort of thing, when is the robot fully taking over versus like when is the robot when is your driver actually driving?
The driver actually only drives towards the game piece. We assist him while intaking it, and then he presses a button to allow the robot to take over and just place the coral on the reef, which will Jan explain in a bit, right now.
Great, yeah, let's pass it over. Jan, I mean, there's so many great things, once again, in terms of even more automation that's gone to us. So let's talk more about that. Your autonomous modes have been awesome as well, like rocking a 5+ here, which is so cool. Anything from your dashboard too you want to highlight?
Yeah, so you can take a look at our dashboard. We have a custom dashboard, and this year, really, as Itai said, for all the automations, we really need a lot of information. So this information comes from the reef. We have a reef demo, and the driver only focuses on going to the right around the right face, and the robot will take over and place wherever. So this is a screen recording from our match. The robot will remember the white places is where there are corals already on the reef. So the robot remembers where it has placed, and me as a commander, I put what other teams have done just by pressing on a reef. We also count for every game pieces to know how close we are to the RP. And also the robot place level is also something that the robot decides itself. So it'll place on the nearest face and on the highest level allowed. And the level allowed is decided based on whatever's free and also whatever's allowed from the dashboard. Because when we do RP, for example, we might want to do L1 even if there are free L4s. So this is our coral automation. We drive to the reef. The robot takes over, and in order to make our path pretty and in order to make them smooth, we tried to implement something with a target, an actual target, and a pre-target, which is a little further away than the actual target. We drive to the pre-target using the angle bisector from the target and our velocity. This way we create a smooth curve and we drive on it. And then our final drive will be just a forward drive when we see the tag full time, and then we place it. So also the placing and all subsystem, everything is automated. When the robot detects using the IRs we have in our conveyor and intake, when the robot detects it has a coral, it just picks it up and goes straight into placing position. And when the driver allows, we'll drive towards the reef, and then the robot will place by itself, and all that is automated. So for our autonomous, it's also, this year we decided not to use any path planning or any sort of path. We do everything on the fly. We only choose our starting position and a feeder to pick up from, and then also allowable branches. So the robot will just choose whatever branch is closest to him, and we'll place on that. This way we save a lot of time, we don't drive to a specific branch. The intake of the drive is based on our camera, Itai has explained, and the reef auto drive is just the same as Stelio. Another cool thing we do is for our vacuum, we have a vacuum sensor in our arm, which detects whether we have a game piece or not in our actual arm in the suction cup. So we use it to speed up the pistons or slow them down when we need to. So when we release, it's just opening a valve, but when we hold a certain vacuum value for each game piece. For algae, we try to hold it more because it's squishy, and for coral, it's easier to hold. So we also need to hold less vacuum. And then the pistons will move really, really fast if there's a leak or anything like that in order to keep that vacuum. But when everything is working correctly, they'll only spin fast for a minute, then create a vacuum, and then slow down and really actually stop. This way we save energy and reduce wear of the system. So for a climb, that's pretty much the last thing. So it's pretty simple. We just open it to a position and then close it up. But we really wanted to make sure we hit that climb. Those are 12 points. That's a lot of points, and it also matters for the RP. So we have something that if the driver presses the climb button 3 seconds, when there's 3 seconds or less left in a match, we'll climb with double the acceleration and double the velocity in order to really ensure that. And we don't usually do it because it puts really unnecessary forces on the system and on the robot. Yeah,
as you get to the end here, there's a good chance that might happen, right?
Yeah.
So for sure on that.
Yeah.
Overall, I mean, this is a phenomenal machine. Once again, Orbit, thank you for taking the time to just highlight and showcase everything that's gone into this. We wish you best of luck. Hopefully, back-to-back defending world champions. We'll see, right? But we're rooting for you, and we hope to see that. Thank you so much, and good luck throughout the rest of the competition.
Thank you.
Thanks for watching. Don't forget to like, subscribe, and click the bell to stay up to date on future fun videos. Build your alliance with so many other FRC alumni who go to Kettering University. Every student at Kettering experiences their cutting-edge co-op programs that seamlessly blend the professional and academic worlds. Kettering co-ops are a fully immersive working experience at the leading edge of industry. Head on over to kettering.edu/FRC to learn more about their incredible programs and to get more information. AndyMark provides superior service with the reliability that teams expect. Check out their sport gearbox and ratchet sport options to their tried and true compliant wheels used by teams all over the world. From mechanical and electrical products to tools and hardware, head on over to andymark.com for your one-stop shop of high quality and affordable solutions.